And I just have a couple of notes for the introduction. So welcome to the 19th episode of the Society for Organic Urban Land Care's 2022 Year of the Ecological Garden series. And it's a weekly series that is aired every Tuesday at this time. SOL is a professional organization that works to promote awareness and practices of organic and ecological land care, and much of the work we do is made possible through the generous and ongoing support of Gaia College. I'm speaking to you today from Ottawa, Ontario, where I live and work in the Anishinaabe-Algonquin territory, and I'd like to make a point of mentioning that that we are joining from all across Turtle Island for these sessions, and so we all have different relationships and treaties in our various territories. But I'm in what is currently known as Ottawa. The format for this presentation, format for today will be a presentation followed by a Q&A. And as I mentioned before I hit record, this session will be recorded, and the recording is made available to registered participants, and this episode will be added to the SOL website. If you have a question but prefer not to be recorded, do please add it in the chat and I can read it out during the Q&A sessions. You're also welcome to raise your hand, and I'll call on you to ask your question directly to Julia if you'd like to do that. And our guest presenter today is Julia Dupuis, and she's going to be presenting in line with this month's theme of soil and compost. Julia is a SOL accredited practitioner and a Soil Food Web certified lab tech. She runs a microscopy. Apparently I lost my capacity to actually speak. I'm going to start that over. Julie is a SOL accredited practitioner and a Soil Food Web certified lab tech. She runs a microscopy lab. Julie, you'll have to pronounce it properly.
Microscopy
Thank
lab.
You. I've said it before, but apparently my tongue says no today. Microscopy lab and compost business called Soils Alive Composting and Consulting. Prior to delving into biology, she was a chemist where she worked and studied inorganic compounds in both water and soil. So thank you very much for coming today, Julia, to give us a rundown on soil testing, something that I know a lot of people know they should be doing but have no idea how to get started on. So if you can give everybody a good intro, I know that's going to be really helpful. So please go ahead.
Thank you, Sandora, and welcome everyone. I'm really excited to be here today. I'm also in Anishinaabe-Algonquin territory, and I love soil, so I'm excited to be giving this talk. Just a quick overview of what I want to discuss today. Physical, chemical, and biological properties of soil, and they all require different tests, and how we can go about selecting a test and understanding the results and how it pertains to our soil. I'm hoping to provide some insight into making these decisions a bit easier this gardening season. So today we're going to touch on soil properties and the different tests to measure each property, a brief comparison of the tests, and when and how often testing should be done. So soil properties, I'm sure a lot of you are familiar with some of them, particularly the physical properties, which include water infiltration, soil textures, including sand, clay, loam, sandy loam or loamy clay, density and compaction. Chemical properties are a bit more in depth. They include cation exchange capacity, pH, organic matter, and of course the amount of different available and exchangeable nutrients. And finally, biological properties look at the living organisms in soil, including bacterial and fungal biomass, protozoa and nematode counts, presence and absence of beneficial and detrimental microorganisms, and higher trophic arthropods, all of which play a big role in not just the soil food web, but the overall food web. So as there are 3 different types of soil properties, there are 3 different types of tests. First, let's get into physical tests. Water infiltration rate. So a moderate water infiltration rate is 50 to 15 to 50 millimeters per hour. This is based on rainfall, but how do we go about measuring that? And what does that mean? Healthy Lake Huron has a really great infographic, which I've referenced here, that uses a coffee can and 800 mils of water. Pour the water into the coffee can, time it, and see how long it takes for the soil to absorb all of the water. The timer should be started as soon as the water hits the ground. Using the coffee can and 800 mils of water, moderate infiltration takes 30 to 100 minutes. Slow infiltration takes longer and rapid infiltration takes less time. So we want the moderate range. And we're going to get into a little bit more later about what impacts water infiltration. Sorry. Bulk density, another physical property, is indicative of how easily the roots will push into the soil. The higher the density, the harder it is for roots to push through. Bulk density can be tested with a large steel ring, a scale, and your oven. The basic idea is to completely dry a known volume of soil and divide the dry weight by the volume. A bulk density higher than 1.6 grams per cubic centimeter can restrict root growth. Similarly to bulk density, compaction measures how easy or hard it is for roots to penetrate the soil. This test requires a soil penetrometer if you want an actual reading. Those can get pricey, so you can use a piece of rebar. You just won't get the actual pressure reading. 150 psi is the threshold. So roots can't push through 150 psi of pressure in the ground. If that pressure is at 6 inches below the surface, that's going to be a problem for roots. If it's 24 inches below the surface, it might not be so bad for roots. So the purpose of the compaction test is to determine how far below the surface of the ground that compaction layer is. And finally, soil texture. To determine clay, sandy clay, loam, silty loam soil. So this is an easy test to do. Taking a jar and filling it with a sample of soil 1/3 to 1/2 full, add water and a little bit of like a spoonful of dish detergent or borax to help the clay settle. Shake it all for a minute or two, and then when it settles, measure the layers. Sandora was saying just before we got started that a lot of people think they have high clay content in their soil, and they don't. It's just because their soil is so compacted. So this will give you an idea of how much silt, and clay there is. And by measuring each as a percentage of the total and plotting on the chart, you get an idea of what type of soil you have. So sandy clay loam, which is not very helpful, or mostly clay. So what do these results tell us? Well, clay soil has a small particle size, high compaction, and low water infiltration rate. Sandy soil has a large particle size, low compaction, and a high water infiltration rate. Loamy soil is in between. Really compacted soil has low water infiltration. So similarly to clay, which is why people sometimes get confused. A little compacted, medium water infiltration rate, which indicates some organic matter, and not compacted at all, which is a high water infiltration rate, more organic matter, or maybe it's just a lot of sand. Soil texture can give us some insight into bulk density and compaction, and also give us an idea of water infiltration, how the roots will grow, and maybe how much life is present. The greater the compaction, the lower the water infiltration rate, which leads to increased runoff. Additionally, higher compaction and bulk density can restrict root growth. The goal is to have soil that is full of air and water pores, spongy enough for roots to penetrate and find nutrients, suitable for microorganisms to have room to move and breathe, enough air and water pores to hold water in the event of high rainfall. So physical tests they can be very informative. They're fairly cheap to do if you're on a budget. And whenever you look at the different results and kind of combine them all, you can get a lot of information about your soil. Chemical tests need to be done in the lab. Obviously that costs money. $25 to $50 is the average rate, I believe. There are numerous labs that do this work across the country, and they're typically accredited by the province. Sometimes you'll get your report with some insight into what your soil needs, but not always. These reports can be helpful in knowing if you have high levels of contaminants or any one particularly readable available nutrient, such as excessive calcium. Organic matter, soil pH, and cation exchange capacity can also be helpful to know, but don't provide a full picture of the soil. An elemental analysis will provide nutrient concentrations in a plant-ready form. Phosphate, which is P2O5, you may have seen before if you've ever had an elemental analysis done on soil, is the phosphorus that is available to plants and what is reported on an elemental analysis. However, P2O5 is in this soluble range down here. That's what's reported. Most chemical analysis only report soluble nutrients, not exchangeable or total, and therefore only offer a limited picture of what is actually present in the soil. Another good example is nitrogen. So nitrogen is typically measured as nitrate or ammonia, so NO3 or NH3. But plants can also absorb nitrogen from nitrogen gas, which is N2, or ammonium, which is NH4. So if our soil test says that we've got X amount of nitrate and Y amount of ammonium, that's only part of the picture. We're not getting the full amount of nitrogen in the soil. Organic matter, pH, and cation exchange capacity are other tests that are done in a chemical analysis. Organic matter is incredibly valuable information as it provides an accurate measure of how much organic matter is present in the soil. 3 to 6% is considered normal for topsoil. More organic matter is always better. And a 1% increase of organic matter results in an increase of water holding capacity of about 3,400 gallons per acre. Increasing organic matter by 1% can be challenging, but if you're adding compost every year, mulching regularly, it can build up over time. pH, a neutral pH is 7, less than 7 is acidic, and greater than 7 is alkaline. Most plants prefer acidic or alkaline soil. So acidic soil is pH 5.5 to 7, and alkaline soil 7 to 8.5. However, as the pH changes, different nutrients become available to the plants. So going back to the nutrient availability, that's the nutrients available at the pH it's measured at. If the pH changes from 5.5 to 6.5, that nutrient availability may also change. On top of that, as the organic matter changes, the pH can also fluctuate. Cation exchange capacity varies by soil texture, and is indicative of how much humus is present. So humus is organic matter. On its own, cation exchange capacity only provides us with a number of positively charged sites available within the soil. Humus has a cation exchange capacity of 100 to 300. If you have loamy soil with a higher CEC than expected, the soil is considered to have a high humus content. Unless you're comparing the standard CEC numbers for different soil textures, CEC on its own isn't very helpful. So this is a sample report from a home gardener. You can see here the organic matter is 5.8%. Which looks good. The pH is fairly close to neutral. And then we have all these values. And next to these values, H or M. And in some cases, you would see an L. So H is high, M is medium, and L is low. And these correspond to the normal range of nutrients expected in the soil. The organic matter is helpful. However, I know this garden and I know that it is not ideal growing conditions. It's a PEI garden, and it is, if you're familiar with PEI soil at all, it's very heavy clay. So this organic matter percentage is not helpful for this garden. Going to the recommendations that came with this report, 4 different types of fertilizers at different application rates were recommended because of the, just going to go back here, based on these results. So calcium was medium and potash was high. So don't add too much potassium because you don't want your potash to increase. But if one of these other elements is low, then you might want to add more of that. These results are not very helpful in organic gardening. They're like a Band-Aid solution. Put one element in and then it throws off the balance of the other elements. So this is not, it's helpful for tracking year over year, but it's not helpful for maintaining a system. Test for biological properties. So a biological assessment is done under a microscope, and a lab tech would look at for nematodes and protozoa, bacterial and fungal biomass, and beneficial versus detrimental microorganisms. Bacteria and fungi are the basis for the soil food web. Without them, we only have dirt, and nothing grows in dirt. Beneficial microorganisms thrive in aerobic conditions, and anaerobic conditions lead to the presence of detrimental species. We learned earlier that soil texture, compaction, and bulk density are indicative of how much pore space is present and if the conditions might be aerobic or anaerobic. The fungi to bacteria ratio to match the plants is based on research done by Dr. Lane Ingham. Lawns, perennials, shrubs, and trees all have different fungi to bacterial needs, with lawns needing the least amount of fungi, and trees needing the highest. Once the fungi to bacterial ratio matches that of the system will more or less take care of itself. This can be really helpful if you're doing a large green space installation. It's a big investment and it can be risky if you don't know if there's enough soil biology to sustain it. If you're planting a tree in an area that has far more bacteria than fungi, it might struggle to establish. But ensuring there's sufficient fungi from the beginning by adding compost or mulch or anything like that to the soil or right after you plant it can help the tree thrive. Protozoa and nematodes are critical to the soil food web. They are responsible for nutrient cycling. Both eat bacteria. Nematodes also eat fungi and other nematodes. Nematodes will also sometimes eat plant roots. Root-feeding nematodes are detrimental. They can wipe out an entire crop or garden before you even know they're there. I've looked at samples with root-feeding nematodes, and the question was, what's happening to my plants? And the answer is, well, it's right there in the form of a nematode. Beneficial protozoa and nematodes will keep bacteria and fungi in check, and the bad ones lead to more anaerobic conditions. So why is soil biology important? Well, more organic matter results in more biology and more biological diversity. Microorganisms form the basis of the soil food web and feed into the food web. Increasing soil biology can also increase garden biodiversity. I've had a lot of questions about grubs in the lawn and what do we do about it? They're part of the soil food web. They're going to turn into insects and then decide if they're a good insect or a bad insect, but grubs need to be there. They're part of the food web. Ensuring sufficient aerobic species are present will help with nutrient cycling so that plants have the nutrients they need when they need it. This is just a quick testing comparison of the three types of testing. So physical tests are free or sometimes included with the chemical analysis. They can be done at home, and they are good indicators as a starting point for something that you're going to track year over year. So you can easily do a water infiltration test in the same or similar conditions in the same part of your garden or landscape each year just to see a change. Chemical tests are $25 to $50 per sample, depending on a basic test or a more extensive test. Also varies by lab. They're done by provincially recognized labs, and the numbers provide the results provide actual numbers to monitor and aid in decisions. Biological test, $50 to $100 per sample. Soil Food Web certified labs are currently only in BC and Ontario, but you can mail samples to them. And these results provide a fungi to bacterial ratio to match the plants, confirmation of aerobic conditions, and the absence of detrimental microorganisms. So just two more things here. So sampling a new space, some things to consider if you're doing a new installation. What was there before? What will be planted? And does the ground need to be built up at all? If you don't know what was in the space before, you'll likely want to start with a chemical test and maybe a biological test. A chemical test will provide info about chemicals or heavy metals present and if there's any remediation of the space required. If pesticides or fungicides were sprayed recently or repeatedly, that might come out in a chemical test. It's likely if that's the case, there isn't much biological life. So a biological test will tell you that. If heavy metals are present, you will need to do a full remediation, which can be quite costly. So certainly something to consider before you go ahead. Vegetables, shrubs, trees, and flowers all have different biological needs. A good estimate is the higher the root biomass, the more fungi required in the soil. So biological assessment can help you determine what's there and what needs to be added in order for the system to be sustaining. Finally, anything added to the soil will impact the soil. So if you're going to bring in a lot of fill or some compost or mulch, you'll want to consider that as part of the whole picture. You may want to do some testing, 1 or 2 tests before and then again afterwards, or one before and one after, depending on the space and what you're bringing in. Sampling year to year, once you've got your space established, if it's a healthy landscape, and you're adding compost annually or biannually, so twice yearly, not every second year, and mulching where necessary, these small steps can go a long way to maintaining an established system. It doesn't hurt to reassess the biology every 2 years, maybe 3 years, not necessary every year, depending on the space. You do want to periodically check in to make sure that life below ground is thriving as much as life above ground. Insufficient compost, too much rain, and other factors can cause conditions to change. So good to check in with that periodically. Physical testing is something that you can do every year. As your organic matter increases in the soil, you should see a change in bulk density, compaction, and water infiltration. So those are things that you can monitor every year. And that's it. So thank you for your time and attention. I hope I was able to provide some helpful information regarding the different types of soil tests available. And now we will have time for questions.
Thank you very much. That was a good overview of sort of what to test for and look at with soil, because I know sometimes it's it can be a matter of going, I don't even know where to start, and often people are sort of just going, they told me I need to test my soil. Or why aren't things growing, and just have a little bit of an overview of what's going on there can be really helpful. If you want to go ahead and end your screen share, then we'll just pop up and have a whole screen. Lovely. And does anybody in the room have questions? If you do, feel free to let me know, put your hand up or unmute, or as I said, you can go ahead and put it in the chat. I did toss a couple of links in the chat while Julia was presenting. One was to the you had a link about the coffee can test. So I went to it, got it checked, made sure I typed it in properly and shared that. So if anybody wants to check that out. And also Oregon State has a good step-by-step instructions on the jar test. So I shared a link to that. So it's exactly the same one that Julia just showed, same process, and it's got step-by-step instructions. I had a couple of things that I was jotting down notes while you were talking. I've got one that's also just a curiosity for me, because actually I years ago worked in a garden center that long before we started even talking about root eating nematodes, and they stopped. They couldn't grow petunias anymore. And I had a suspicion there was something that had gotten into the water that was a species specific, and I was curious. Are root eating nematodes generally plant species specific, or are they generalists? Do they attack everything in your landscape, or do you get one species that attacks all of your tomatoes or something like that?
That's a great question. From what I understand, they will go for any root available. So bacterial feeding nematodes will go specifically after bacteria, fungal feeding nematodes specifically after fungi, and root feeding nematodes specifically after roots. There may be one type of root feeding nematode that prefers one root over another. I don't know about that. I'm not even sure if there's any research to confirm that.
Yeah,
But
it's
good
amazing.
question.
Well, it's amazing how new a lot of the soil science really is. I know the first paper was on the topic of the soil microbiology. It was published in my lifetime, and well, I'm not that old, so that was the very first one that Elaine Ingham did. And so, like, okay, that's how far we've come. So it's not a wonder we don't all know what we. It's not in all the books, and it's not well explained and everything, because in a lot of ways, the soil science and the testing from a biological as opposed to chemical standpoint is really new.
Yeah, soil life is
Yeah.
a very new concept. We didn't realize 30 years ago, we didn't know that there was life in the soil, and now we know so much more about it.
Yeah, and just how complex that is, because yeah, I know we couldn't culture it in the petri dishes, so we assumed it wasn't there, and then we started genetic mapping it, and there's just the diversity of it. We have no idea what most of it does still. So we know that if it's really diverse and happy, then the plants do well. But
Yeah.
what every
Yeah.
specific thing does, we still we don't know. We know how we have some good things on how to keep it happy. I also had another question, because you mentioned a lot of the reports, the soil reports come back with sort of high, low, medium nutrient levels. What system is the baseline for that from? Is it like an agricultural sort of production? Is it perennial landscapes? Do they
I
provide
think
any info on what
I think it's agricultural based. All of the soil testing labs that I've looked at they'll do landscape and garden analysis, but their focus is agricultural. So this sample report is from PEI, and I mean, the soil in PEI is going to be fairly consistent unless you're a potato farmer and you're sucking nutrients out of a year and putting them back in and the next year with a different crop. But it's not really a great, it wasn't helpful for this garden was, tomatoes and cucumbers, and it's not helpful when you're growing those kinds of crops. You don't need that much information. And I think a lot of people don't know what to do with the information because it's so much information, and in a backyard garden or a green space, it's just not relevant to it.
Yeah, I have been sort of realizing more and more just how much of our garden advice that is often given out, or information, is actually based, it comes from agriculture, and then when we turn around, we try to apply it to home scale gardens or to perennial landscapes. The guidance doesn't have the outcomes that we tend to expect because it was really done for a different system. Nate has asked a question in the chat. After getting a soil test done and finding the soil is deficient in certain materials, how do you amend soil to meet the requirements without using fertilizer? And I suspect Nate means like what would generally be called in shorthand, like a chemical fertilizer or a synthetic fertilizer.
I'm going to assume he means that too. So my solution is always compost. There's lots of nutrients in compost, and you can put compost on. You may end up with excess phosphate. That's okay. It's not going to ruin anything. But compost also makes nutrients available in the plant ready form. And it's organic. It's natural. I mean, it's not, unless you're using, I'm going to say, dirty inputs, which are like laced with contaminants, then it's pretty clean, and it's going to have the nutrients that you need. So compost is always the answer.
Yes, I've been saying that one for a while. It's like compacted soil, compost. soil drains too fast, compost. Things that you have an excess of certain things. I've even seen situations where compost is the recommended thing for binding up contaminants. So you still wouldn't grow food in it, but to actually stop contaminants from moving
Yeah,
to add more organic matter to the soil.
I guess.
It's like it's not a remediation, but it was about preventing leaching, and it was just sort of funny. I'm like, it doesn't seem to matter what the question is. The answer is add some compost.
So I guess to expand on that answer, Nate, the better question is how much compost, and where do you get your compost? There's different qualities of compost available. Worm castings are a fairly good quality. There's lots of nutrients in it. Mushroom compost I wouldn't recommend it. It's pretty low biology, and I'm not sure about its nutritional breakdown. But you also want to look at like roughly 1 ton of compost per acre. So I think a lot of people put compost out and like, okay, I put compost, so it's fine and it's going to be enough, and you need more, and then maybe more on top of it. You can never have too much compost. I think the budget is probably more the limiting factor to the volume of the compost that you're using. So I hope that answers your question.
Yeah, and I would actually just add a quick thing about because I agree that more organic matter is generally better, but not, as you said, not all composts are created equal. Not all organic matter sources are created equal. So things like black earth that come out of a wetland, or like usually that's what's in the bottom of peat bogs, and it's very commonly sourced. I know it's more of an Eastern Canada, and I'm including Ontario in that and Quebec in that, than Western Canada, but it's high in organic matter, but it's kind of a monoculture of organic matter. So you don't get that great diversity that you get with a good, well-made compost. So you're adding almost an inert material as when you add black earth versus something that comes from a compost. The diversity of biology in there is just so much greater. It's a really different thing. So yeah, not all compost is created equal, and not all sources of organic matter is created equal. And kind of like you said about compost is the answer is compost. And I also, people like, what do you compost? And I'm like, as many different things as I can get my hands on, because the more diverse the compost, the more diverse the biology. And you can actually even address a certain amount of disease loading in your ecosystem by adding, if you can't eliminate something, add a whole bunch more of everything else, and it
balances
shrinks
out
the population. I got ahead of damp off in my potted seedlings this year by adding compost to the supposedly sterile potting mix, and the damp off stopped. So I added more fungus instead of trying to get rid of the fungus, and hey, it worked.
Because the aerobic fungus battled out the anaerobic fungus. So the aerobic fungus took over in the aerobic system.
Yep, and it's like, well, there we go. It's rather than trying to get rid of, I added more, and it did the trick. So Nick has a question: is there a time of year that's best for certain tests?
No, there really isn't. I had this question a lot lately about the best time to do a biological assessment. And I mean, it's if you're starting with a new installation, then and you want to know that information up front and it's going to be part of your decision making, then certainly do it ahead of time. But it doesn't hurt to do it after the fact and then realize, okay, well, I need to add, you can always add compost or compost extract to the ground. Sometimes it's good to plant things and see what happens, and see where you're seeing the differences, and where something is performing really well and something is lagging, or where there's different water pooling or it's drying out too quickly. So no, there is no best time of year for a certain test.
Is there's some value to repeating tests at the same time of year, though, just so it makes it easier to compare progress of results?
For physical tests, yes. chemical tests, I don't think it really matters because those are typically done at the beginning of the year so that you can add your nutrients before planting. For a biological test, as long as the everything has to be awake, like all the microorganisms have to be not dormant and relatively dried out. But I mean, any time from May to August or September, depending on what you want, it's going to change year to year and month to month anyway. So you're not going to be able to repeat a biological test.
Yep, fair enough. And Lynn asked, is it effective to just spread compost on top of the soil, or should it be worked in?
That's a great question. So both, actually. If your soil is really compacted, you want to get the compost into it. The downside of turning the soil to work compost in is that you're exposing the microorganisms and you're possibly killing them. However, you're replenishing them with that compost. If the ground is soft and easy to work, then you can simply spread the compost on top and the microorganisms are going to be able to move back and forth between the compost you just put down and the soil. If it's compacted though, there might be fewer microorganisms or there might be below the top layer, so you want to kind of work it a little bit. So that it really depends on the soil type, if that answers your question.
Yeah, I saw, I was at a conference that Elaine Ingham spoke at a bit, and I think I'm not sure if it was there or one of her other presentations, but I remember her saying you can till once.
Yeah.
Till once, put your compost on, break up the soil and get the biology down into it, and then don't till and then don't ever till again. Basically,
Yeah,
it's
so that first application might need to be cut in, but after that it can just be added to the top. And compost can also be added as an extract or a tea. So compost extract is basically compost in water with lots of oxygen in it. Whereas compost tea, you add some other things to it. And compost extract can be sprayed right on the soil and then the microorganisms will go into the soil.
Yeah, they move around with water.
Yeah.
Yeah, and actually one thing when you're answering Nick's question about sort of times to do tests, something that sort of just crossed my mind when you were saying about that, about even to go ahead and plant and see how things are doing, is I think it's something I've been starting to become a proponent for, is right after a huge disturbance, when you've probably disrupted, like if there's been construction or tilling or the site's been regraded, which a lot of new gardeners are working with, is and usually your bacteria levels are going to be high at that point because of all the disruption, because you've lost all the fungi, is to actually plant an annual garden. I years of being a landscape designer, it was always perennials, perennials, perennials. And I'm like, seed a cover crop or plant an annual garden to see what's going on and see how everything grows, and also to just sort of start to kickstart some of the soil biology, which you can do with adding the compost and planting the annuals. And the annuals will be fine in the high bacteria level. And then once they've had a season to sort of start to rehabilitate the soil and all that high bacteria situation, and start to break down a little bit in it and start to get the fungi going, and then put your perennials in, so that you can do things in stages too. And if you're dealing with a highly disrupted site that's got the really high bacteria, but your long-term goal is a woody ecosystem, which is going to need more of the fungi, you can fill in some of those steps in between.
Yeah. I mean, if you're going to do like a big perennial shrub tree installation, I think it would be best to do the testing up front and then maybe bring in some high fungal compost or some extra mulch just to make up for low fungi present. But I mean, this is like, we're talking like thousands of dollars spent on plants that you want them to survive. So take the time and do the test and make sure that there's enough biology in the soil to sustain the system.
Yeah, and not taking care of the soil is something that we can really see in a lot of urban plantings with the average lifespan of a tree in an urban planting by the municipalities. I know ranges anywhere from 3 to 7 years for the average lifespans, and that's not because the trees aren't healthy when they go in. It's because we don't take care of the soil first.
Yeah.
So yeah, and
Yeah.
I always sort of shake my head because those trees aren't cheap and the survival rates are so low. And I'm like, if we just took care of the soil first,
Yeah.
we wouldn't be replacing them every few years.
I
Um,
do have a funny story about a tree on my street, but we can, if there's any more questions, we'll get to the questions first. I can save the
I think
story.
that's all the questions. So if you want to do the story, and then that'll probably wrap us up.
So I have a neighbor who has a tree, and every year he tries harder to help save the tree. So last year, I think he was putting in some sand to weigh down the roots because the tree was not stable. And I just shook my head and walked inside because the tree, he's got his driveways paved, and then he's got patio stones, and he's got rocks all over the garden and a tree in the center. I thought the tree can't survive because one, there's too much compaction under all that rock and the roots can't get established. Two, there's no fungi under there to feed the tree because it can't get there. You can't grow a tree in concrete, bottom line. And then like this was in the spring and then in the fall, and he's just constantly out there trying to like help this tree survive. And you can't grow a tree in concrete.
Yeah, when you take away all of their community and all of their soil, and then expect them to grow, it's what wasn't there a kids thing about like I remember some story about like a palm tree or something got cut in half, and the one creature wanted the top because it was so green and full, and the other creature wanted the bottom, took the bottom because it had the roots, and then of course that's what grew. Just a kid's book years ago, and it's just I should look up what it was, but it's like the story actually had it right. You need the roots to be well. If you've got the roots, the tree will thrive. We can't just look at the top. It's got it. If we take care of what's below ground, we don't have to do much with what's above. The tree can take care of that. But if we take away their biology and we take away their community, they just can't thrive.
Yeah.
They need soil, and there's not really any shortcuts for that, other than we can rehabilitate soil by adding compost.
Yeah.
All right. Well, thank you very much. That was excellent. And yeah, once the Zoom processes the recording, I'll get it added to the Soul website and send out the link to everybody. So thanks everyone for coming. And we will be continuing with this theme of soil and compost next week. So you can sign up through Eventbrite. It's just the next date on the list, and I'll include the link in the email that I sent out. So go ahead and sign up for next week, and we'll keep learning about soil and compost and biology. Thanks, everyone.
Thanks, everyone.